Hello everyone and welcome to the lecture on kubectl job and cronjob commands. So this will be a combined lecture on both job as well as cronjob commands. So first we'll set the alias k equal to kubectl. Next, how to list all the jobs, k get jobs. So this will list all jobs in the current namespace and it shows job status, completions and duration. So the output will look something like this. So job name, completions, duration and age. Next, have list jobs across all namespaces. So k get jobs dash capital A. So this will list all jobs across all namespaces and this is essential for cluster-wide job monitoring. So the output will look something like this. You have namespace as the first column followed by the job name, completions, durations and age. Next, how to describe a job. K get describe job followed by the job name and this shows detailed information about a specific job including events, conditions and pod template. So this is how the output will look like. You have name, namespace, selector, labels, annotations, parallelism, completions and all the rest of the fields. And lastly, we have all the events. Next is to create a simple job. So k create job, job name, image followed by what command you want to run. So this creates a basic job that runs a single container with the specified command. So this will give the output saying that the job is created and the resulting YAML in the system will be something like this. You have batch v1 kind job, then any labels and the name that you have specified. Since we did not specify namespace, it will come as default namespace and other parameters which are default like completions, parallelism, backoff limit and all other fields. Next, create job with shell command. So k create job, shell job, image and followed by dash dash and we are saying create a shell job, shell command. So this stands for sh shell and then run this command. So echo hello and then one more and sleep for 30 seconds. In the previous we have dash dash and direct echo. But if we have some more than one command, we have to use this particular syntax shell and run this command and then we do a double quote and this whole thing goes into the busybox image container. And this creates a job that executes shell commands using the sh-c for complex operations. And you will get, okay, this job is created and the output will look something like this. All other fields are similar, but if I just come down to the part where so under the container, you will see command. It will look something like this. Shell, run this command, echo hello and sleep 30 and the busybox image that we have specified and rest of the other fields. Next is to generate a job YAML. So k create job, my job followed by the image name. So you have to do dry run equal to client o output YAML and dash dash echo hello. So this generates a job YAML without creating the resource and this is useful for customizing before applying. So this will generate the template and template will look something like this. So all your fields and this is the command echo hello and the image and this will have the same name, container name and the job name will be same and restart policy equal to never. So there are only two options, restart policy never or on failure. So get job logs. So k logs followed by the job name and this retrieves logs from all pods created by the specified job. And let's say we just gave echo hello world, so that was the log. So it will just print out that statement. If container has some other logs, that will print out those logs. So get job pods. So you can do k get pods and selector followed by the job name. So this will give list all pods created by a specific job using the label selector. So you will get information like this. So you will have this pod which was created by the job and what was the status, completed or not, restarts and what is the age. So this is 2 minutes. So deleting a job is k delete job followed by the job name. So deletes the job and all its associated pods. This can be used for cleanup after job completion. So you will get a message saying that the job is deleted. Next is to list cron jobs. Now we are shifting focus and talking about cron jobs. So K get cron jobs. So list all cron jobs showing schedule, suspend status, active jobs and last schedule time. So output will look something like this. You have name, what is the schedule, suspend or not, active or not, last schedule and the age. Next is to list cron jobs across all namespaces. So K get cron jobs dash capital A, list cron jobs across all namespaces for cluster wide monitoring, and only extra field will be namespace. So default, kube system, monitoring, logging, sort manager or any other namespace also. Describe cron job. So K describe cron job followed by the name of the cron job. And this shows detailed cron job information including schedule, job template and execution history. And this is the complete description of the cron job. So name, namespace, labels, annotation, schedule. This is the important part. Concurrency policy and rest of the other fields along with the events at the end. So next is to create cron job every minute. So K create cron job followed by the name of the cron job, which image you want to use in the container and schedule. So this is the syntax. First is the minute field. So star divide by 1, it says every minute and echo hello. So this is a very simple cron job that will run every minute and it will print out hello. So creates a cron jobs that runs every minute using cron schedule format. And this is the resulting YAML in the system. So kind cron job and the name which you have given. Namespace is default. And these are all the default fields. And underneath you will have schedule which we have specified. And this was the command that it will run every minute. So create cron job daily. So K create cron job daily backup. Image we are using is busybox and schedule. So 0 to star and then this shell, run the shell command sh dash c. So in this here we are just doing an echo daily backup at 2 a.m. So this creates a cron job that runs daily at 2 a.m. using standard cron syntax. So this is the syntax for running every day at 2 o'clock. So 20. And this star is for every day. So this is how it will look like. So cron job, name of the cron job that we specified. And under containers, you will see this command will be executed in the shell echo daily backup at 2 a.m. And this is the schedule. Generate cron job YAML. So if you want to generate the YAML and modify first, then this command create cron job image busybox schedule, let's say 0 star by then stars divide by 6 star. So I'll just explain also, and then dry run client OYAML and what we want to. So this we are just running a simple only one command, and this generates cron job YAML without creating the resource for customization. That's why we are using dry run client, and this set the cron schedule to run every 6 hours. So this is the format. So if you see star divide by some number, that means you have to like that many number of times in a like every 6 hours at minute. So this is 0 minute, and divide by 6 means this per day, then every 0, 0, 6, 12 and 18. So this is how the cron syntax looks like. And same thing cron job, we are just running a simple command. That's why we are not giving sh-c, and this is the schedule. Create job from cron job. So this situation can also arise. You have a cron job, but you want to make a job out of it, like a one-time job. So K create job from cron job, and we call this one-time run as test job. So creates a one-time job using the template from an existing cron job, and this is perfect for testing cron job configurations. So you will get a message saying that it's created. Suspend a cron job. So you will run K edit, then you edit name of the cron job, then you just have to go to the spec section, under specification suspend, you have to make it as true. So suspends a cron job to prevent new job executions while keeping the cron job definition. So you want to keep the template, but we don't want to run anymore. So after you make this add this line, you'll just make it, you'll get a message saying that it's edited. Resume a cron job. So let's say we have suspended. Now we want to resume it back. So again, we edit the cron job YAML and change suspend from true to false. So it resumes a suspended cron job to continue scheduled job executions. So you will get a message saying that it is edited. Get cron job active jobs. So get jobs -l for selector and the job name and what you want to select on. So my cron job. So list active jobs created by a specific cron job using label selector, and it will give you the output like this. Deleting a cron job. So delete cron job, name of the cron job. Deletes the cron job and stops future scheduled executions. Active jobs continue running, the ones which are currently active. So you'll get a message saying that it's deleted. Next is to create job with multiple completions. So first we'll generate the YAML, create job, parallel job, and image busybox, dry run, client, OYAML. So we are generating the output, and in the YAML we want shell execution and this particular command echo task completed and sleep 10 seconds. Then we output it to job.yaml. Then we edit, and under spec we make completions equal to 3. Then we apply the job YAML. So this creates a job that runs 3 successful completions by generating YAML, modifying it to add completions, configuration, and applying the job. So this is the final outcome after you make the edits. So job. So you just come to spec sections and completions equal to 3, right? So we just modify this field. Rest all we have generated from the YAML through dry run. Next is to create job with parallelism. So generate job YAML first. So we call it parallel worker, busybox image, dry run client, output YAML. Then in the YAML we want echo worker started and sleep for 20 seconds. And again modify the job.yaml, add parallelism equal to 2 and apply. So creates a job that runs 2 pods in parallel by generating YAML, editing to add parallelism, configuration, and applying the job. So this is the final outcome. So parallelism equal to 2. Rest all field is fine generated by the YAML. Set job back off limit. So edit job. Let's say this job already exists. My job in the system, and we just have to specify back off limit. And this sets the maximum number of retries for failed job attempts. Default is 6 retries. So this is the final outcome after modifying. So we are just back off limit. Default was 6, we made it 3. And these are the defaults like completions and parallelism. Next is to set job active deadline. So edit job, name of the job, and we want to set the active deadline seconds. So we are setting 300 seconds or 5 minutes. So this sets the maximum duration 5 minutes before the job is terminated, regardless of completion status. So this is important in case in production environment, some pod may take infinite amount of time. So we want to have some kind of threshold. So this is just an example, 5 minutes. But let's say you can set up a comfortable 1 hour or few hours. So this is the resulting YAML, and under spec section we add this active deadline seconds, so 300. And this is the default, and in the previous, let's say back off limit from 6 we have made it 3, and the rest all fields look something like this. Okay, next command, set job TTL time to live after finished. So edit job, edit the job YAML. So under spec section, TTL seconds after finished. So how long to keep the job status or history, we can say. So this is in seconds, right? So automatically deletes the job and its pods 100 seconds after completion for cleanup. So we are just setting, we are editing the job, and under the section here last, this comes under, again under, it comes under spec section, right? Spec sections, so it is 100 seconds. Next is to set cron job concurrency policy. So edit cron job, name of the cron job, and we'll modify directly. So concurrency policy equal to forbid. So this sets the concurrency policy, and allow is default, and forbid, so this will skip if previous still running, or replace, so kill previous. So basically in future it will forbid concurrent runs, right? So allow is the default, so it will always allow. If parallelism is set, it will allow it to run parallel. Or we have third, which is replace, so it will kill previous and run a new one. So we are setting concurrency policy. This is under also spec section. So we are doing for cron job. Set cron job history limits. So edit cron job and the name of the cron job, and under section spec section we have how much history you want to keep. Successful jobs history limit 3. Failed jobs history limit equal to 1. So this controls how many completed and failed job records to retain for history. And this is how it looks like. So under spec section cron job, so we just add failed jobs history limit equal to 1 and successful jobs history limit equal to 3. So this is under spec section. So you have 2 spaces after that, after the start of a line. So watch job status. So get jobs -w for watch. So monitors job status changes in real time, shows completions and durations as jobs progress. So you will get some output like this. So it will keep changing, it will keep adding. So this, as they change, it will keep adding or it will keep updating on the screen itself. So watch cron job status. So get cron jobs and -w watch. So monitors cron job status changes, including active job count and last schedule time. So this is again same, but specifically for cron jobs. You can see the schedule, suspend, active, last schedule, and age column also. Get job events. So get events, field sector. So let's say involved objects.name equal to my job. So specific to a specific job. Shows events related to a specific job, including creation, scheduling, and completion events. So this is how the output will look like. So this is for my job, all the events that has happened. So this can be seen through the describe also, but this is going straight to the section in which we are interested. Get failed jobs. So get jobs dash field sector status dot conditions type equal to failed. So list all jobs that have failed using field sector on job conditions. So this will give all failed jobs, right? So this is how it will look like. So these 2 jobs have failed. Okay, get completed jobs. So get jobs field sector status dot conditions and type equal to complete. So list all successfully completed jobs using field sector on completion status. So this is how it will look like. So you can see completions all have completed 1 by 1, 8 by 8, 1 by 1. So delete all completed jobs. So delete jobs field sector status conditions type equal to complete. So removes all completed jobs from the namespace for cleanup purposes. So this will just delete all the completed jobs. Create job with resource limits. So first we'll generate the job YAML. So create job, resource job, image, then dry run equal to client YAML, output YAML. And in the job we are saying shell, execute this command. Within the shell, echo starting and sleep, because 2 commands. So we are using the shell -c. And we are just making it go to job.yaml first, then modify, and then we add the resource limits. So this is the max and this is the minimum. So 100 milli core CPU and 64 MB memory minimum, and then 128 and 500. And then finally apply the job. So this creates a job with resource limits using the VI, and then we add the resource limits manually by editing the YAML spec and apply the YAML finally. So this is the changes that we are doing. So under resources, right, we have to modify, because this cannot be specified directly through the command line. So resources, limits, CPU memory, and request. So create job with environment variables. So generate job YAML. So we are creating a job name env job busybox image. First we generate the YAML, and this is the command that will run in the shell. Hello $name from $env. This will come from the environment variable. So we'll add this to in the container name world, and let's say env Kubernetes. So it will print hello world from Kubernetes. We apply the job, and this creates a job that references environment variables. We add name and env and apply. So this is how it will look like. So we'll add this section env, name and env. And this part we have generated, right? So this part came from the command itself. Only we added this particular section. So create job with config map. So first we create the config map saying the name is job config, and from literal message and keys message and hello from config map. Then we create a job, config job, busybox, and client OYAML, shell command, echo $message. Then job.yaml, modify, and environment from, we are doing a config map reference. So this is the name, exact name, job config, and the value will come from here, hello from config map. So it will say echo. So not echo, it will just print out hello from config map. So creates config map with literal data and job that can reference it. Configure env from or env fields manually to inject config map values into the job containers. So this is the total complete YAML. So this all we came from the command itself, and we just added env from config map ref and the name of the config map. Create job with secret. So first we create the secret, and we call it job secret from literal password equal to, we are given some password. Then we do a create job, secret job, image busybox, OYAML, shell command, password is $password. Then we modify the YAML, and we add env name, password, value from secret keyref, which is here, job secret, and we apply the YAML. So this creates a secret with literal data and job that can reference it. Configure env from or env fields manually to inject secret values into job containers securely. And this is how the YAML will look like. So in the env section, which is under containers, spec containers, password, value from, secret key ref, job secret, and the key. So this is the key in the secret here. This is the key. And this is how we inject a value or data from secrets. And this is just for testing. Create job with restart policy. So generate job YAML. So restart job, image busybox, dry run equal to client OYAML, then shell command, exit 1. So we then we modify the job YAML, and restart policy default is never. There are only two options, never or on failure. So we change never to on failure. So sets restart policy to on failure for job containers that should restart on failure. This allows the pod to retry when the container exits with a non-zero status. So this we are changing only this particular field, restart policy. So troubleshoot job issues. So first we do a describe. So there are 3 commands. First we do a describe on the job. We can do a getting the pods, all the pods that belong to a job using label selector, and we can do logs based on the label selector. So these 3 are used to troubleshoot any job issues. So checking job details. list related pods and view all pod logs, right? Because this is a label setter. So this will first is the describe, right? So we do a describe on the job. So we just check out everything looks all right, and mostly we have to go and check the event section at the end whether any failed events are there or not. So it will show some failure or image pull back off or something. Then we get all the pods belonging to a job, and we can do so this is in the this pod is just echoing hello world. That's why this shows up as a log. And that's all. Thanks for watching.